In this video we will have a look at inheritance. We have already looked at classes and we created a class called cars, and then we created two instances of these classes. So we created two car object instances, and for this video we will have a look at class inheritance. Now let's say a company sells all cars with automatic gearboxes only, and all of them have a spare tyre. So every single car this company sells has an automatic gearbox and a spare tyre. So rather than defining this on every single class we create, instead we can inherit those properties from a base class. So we have them defined in the parent, or it's even called a base class over here called all cars, and we could have anything in this class that every single car in the company will inherit. Then we can create other class definitions, and we make the other classes a child class, or also known as a subclass of the base or parent class. And this company might want to break its cars down into the type of cars it sells. So estate, family car, saloon, etc. are shown in the middle boxes, and because all of the estate or family cars have 3 rows of seats and an extended boot, and the saloon cars have 2 rows of seats and a standard sized boot, we can define these attributes by themselves as well. And then we can create child classes of these classes, so we do not have to recreate these attributes as well. Now we have a third layer of classes, and these will be the child classes of the type of car classes. The middle ones, estate and saloon, and in here will be the details of each particular car, such as the make, model, fuel type, mileage, etc. And the class will inherit the properties of the parent classes, estate and saloon, and all cars. So we have just one child class in our example, and it can inherit from one or more parent class. So we can inherit from the estate class or the saloon class, for example. But since it's a car that can be of any type of car, it makes sense to inherit from all types of cars. So we may as well inherit from estate and saloon. By the way, this is also known as multiple class inheritance, by inheriting from one or more parent classes. So a child class can inherit from one or more parent classes. So we do this so we do not have to recreate code. We don't have to recreate the automatic gearbox and the spare tyre, or even the extended boot and the 3 rows of seats for the estate car. We don't have to recreate them in different classes. We could just utilise the code that's already been created in the parent classes instead. And if anything changes in the parent classes, we just have to change them there, and the child classes will inherit whatever changes have been made in the parent classes. So let's have a look at this and how it all works in PyCharm. So for the purpose of the hands-on demo, let's create a 2-layer hierarchy. Let's create a child class and a parent class. Let's ignore the type of cars in the middle, the estate and the saloon. So let's create the very top box, all cars, with a spare tyre and an automatic gearbox. And then let's create the very bottom box, which will be a child class of all cars, and the bottom box will be called car. We are now in PyCharm, and let's create the class all cars to represent all of the cars that we sell at the company. Now let's create the blueprint for our class and create the attributes. However, let's only specify the attributes that will be the same for all of the cars, as we have seen on the PowerPoint. So let's say every single car we sell will be automatic and will come with a spare tyre. So we can include this in the base class that will be inherited by all child classes. Now we will create a child class called car. This will be the blueprint to create each individual car. Now in our child class, which we will call car, we will pass the parent class all cars in the parenthesis. So we now have included a reference to the base class, or sometimes called parent class. And over here after self, we will specify the parameters of our attributes. So now the class car inherits all of the attributes of all cars, and it will also inherit the methods. We'll create some methods shortly of all cars as well. So anything in all cars, attributes and methods, will be inherited by the child class car. And in our car class, we will have the attributes, make, model, fuel type, colour and mileage. Now let's create 2 object instances, and these will be 2 cars. One will be an Audi and the other one will be a BMW. So car underscore 1 and car underscore 2 will represent the details or the specification of 2 cars. Next, let's create a print statement using a formatted string to print the specification for car underscore 1. And every time we hit the dot notation, we can see the attributes or the functions inside here. Make, model, mileage, gearbox, colour. But if we notice, these are belonging to the car class, these 3 here. And the gearbox, all cars, belongs to the all cars class, as well as the spare tyre, all cars. And then we've got fuel type as well. That is part of the car class. Now let's finish off the rest of the print statement and then we can run the file. So the instance car_1 belongs to the car class, we can see here, and all of the attributes we have specified here, make, model, fuel type, colour and mileage, are all parts of the car class. We can see them here. Make, model, fuel type, colour and mileage. Now if we have missed the self keyword in here, now if we run the file, we can print our car and the attributes for car_1 and the print statement here. And we get the specification of this car is Audi A4 diesel grey 20,000 miles or 20,000. However, since we have a reference to the parent class, all cars, we're able to print the attributes for our gearbox and spare tyre as well. So we can use the inheritance feature here. So let's include these two attributes in our print statement at the very end. And now if we run the file again, we can see at the very end spare tyre included and automatic for the gearbox. So we can see we are able to print these by referencing the parent class, and this means we do not need to keep on repeatedly creating the code for those two parameters or those two arguments, since they are going to be the same for all cars. We just reference them in the base class and then use them when we need to. And this also works for methods as well. We can inherit methods. So let's add two methods to the base class. Let's make them as simple as possible. The first one will print the current miles the car's done. We will call the method miles and print this to the screen. Then reference the make attribute, this make of the car's done, and refer to the mileage attribute and then miles. So we are creating these methods as part of the all car class, the base class. Now let's print the statement by calling it car_1.miles. So down here we want to print car_1.miles, and let's run the file. So we can see this Audi has done 20,000 miles. The Audi belongs to the car class, but it's referencing the method that belongs to the all cars class. So it's inheriting methods as well. We could make this a little bit more prettier. Let's run the file again. And that looks better. So this Audi has done 20,000 miles. If we create another one, let's add another method to add 2,000 miles to car2. Let's call it increase_miles, and it will be self.mileage plus equals 2000. And we will use the return statement to return the value. So it's return space self.mileage. And to print the output, we'll use the print statement. Now we can see this method here belongs to the all cars class, but we will be using it with car_2 here, which belongs to the car class. So let's, down here, it will be print parentheses car_2.increase_miles, and let's run the file. So it's complaining it cannot concatenate strings with integer values. So let's change the mileage to be an integer value down here. Let's take the commas out and let's run the file again. And now we can see it's added 2,000 to 40,000 and it's come back with 42,000. So although we are playing with object instances car_2, which is within the car class, we are using the method within the all cars class. And this might not be an ideal example to use to increase the mileage. A better example may have been to increase the cost instead. Let's say due to inflation all of the cars were increased by 5%. So that would have been a better example. But the whole point of this is you can inherit methods. We can also override a method by creating it again in the child class. So in our example, let's say we wanted to change the mileage to 5,000 miles instead of 2,000. Now when we run the file, it should print 45,000 miles and not 42,000 miles. So let's try that. And what we would do for this is let's copy the method to start with and paste it in again in the child class car. And let's change the value to 5,000 instead. Now if we run the file again, we've already got the print statement here for car_2.increase_miles. And we can see it's printed out 45,000 instead of 42,000. So it's overridden the method. So you can do that for specific things as well. And again, maybe a better example of this would have been cost here as well. So let's say the parent class, we were increasing the price by £2,000 on all cars, but we wanted to override this for a specific car to £5,000, or 2% and 5%. Now there's another useful feature you could use if you wanted to see more information about the class. So what we will do here is if we run print and in parentheses type help, and then in parentheses again type the name of the class. For us it's car. And now if we run the file, we can see some information about the car class. If we scroll up, so from here it shows us the car class, and it shows us the method resolution order. So the order it takes, it starts off from a bottom top approach, so it looks at cars first, and then if it doesn't find anything, it looks at all cars, and then the built-in .object. And this is the order in which a programming language resolves a method or attribute, and is particularly important in Python as Python supports multiple inheritance. Object is the base for all classes, that all classes inherit from it. Essentially it has a lot of the default functions. And then we see the methods defined here as well. So you can see the methods it's picked up. It's picked up this method from all cars, increase underscore miles. Actually it says it here, methods inherited from all cars, miles. So it might be useful if you wanted to troubleshoot further, or just wanted to have a look at some information about the class itself. And that's it for this video. That's a high level overview of class inheritance.